Hello guys, I'm Prince and today we'll delve into something innovative and game changing. That's the Smart Material Balance Calculator. The Smart Material Balance Calculator is an innovative tool which was being developed by my teammate in the person of Palmer and myself. This tool or this Smart Material Balance Calculator was built to solve most of the material balances that we encounter in CPC, that's chemical process calculations. And this smart material balance calculator also ensures that our calculations are performed accurately and also gives us faster results as compared to when we work manually. And also, I'll urge all of us to stick around because you're about to see how this smart material balance calculator works. And trust me, it's going to be mind blowing. So, what can this simulator do? Or what can this smart material balance calculator do? So, firstly, this smart material balance calculator can solve most material balance problems involving single or multiple reactions, as well as reactive and also non-reactive systems. This smart material balance calculator also has a user-friendly interface and also interactive. It has a user-friendly graphical user interface and also interactive between the system and the user. Though it also has features for checking errors and also gives us prior alerts on what we are doing. It also gives us instant results. And this smart material balance calculator is perfect and highly recommended for students, that's chemical, petrochemical engineering students, as well as other engineering students or other students that may find it profitable. It's also perfect for chemical engineers and also process simulation enthusiasts. So how was this smart material balance calculator developed? So this a smart material balance calculator, we can call it I would say it's something like a simulator. It was built using Python language and leveraging it with Streamlit to create a clean, interactive web browser that anyone can open on the web. So this smart material balance a calculator was being developed by using Python and leveraging it with Streamlit for like a an enhanced graphical user interface. And also the core engine of this smart material balance calculator uses smart algorithms to ensure that the reactive and non-reactive systems are solved automatically. So fast forward, as we can all see, this is the graphical user interface of my smart material balance calculator. So this is it, and I'd like to take you through some of the features of this simulator or our smart material balance calculator. So from here we can see the select system type and we can toggle between non-reactive and also reactive systems. We can also select a number of streams, specify our inlet streams, our outlet streams, and also finally the simulator or smart material balance calculator performs the material balances for us. So maybe in the course of we inputting our values, if you made some errors, it means it's going to be tick red here. It means our system is not balanced. So real quick, let's also move on to the reactive system type. So this is also the interface for the reactive systems. Real quick, I think I have some questions here that I would like us to test it with a simulator. And yeah, so this is the question. A fresh feed stream containing 100 moles of nitrogen and 200 moles of hydrogen is fed into a continuous reactor to produce ammonia. The reactor does not achieve 100% conversion. An analysis of the reactor outlet shows that 80 mole of ammonia has been produced. So you are calculating the final stream composition, the fractional conversion of the limiting reagent or reactant, the reaction yield, and also the plant yield. So let's fast forward, move on to a simulator or a smart material balance calculator. So from here, let's specify a number of reactants, and we know a number of reactants is 2 from the reaction that was given in the equation. So we want to produce ammonia and we just need 2 reactants, which is nitrogen and hydrogen. So a number of reactants here is 2. And for a number of products, we just want one product, which is ammonia gas. So reduce this to 2. Reduce this to 1. So we now come to the section where we specify our components. So this is for the reactant side. So we specify our reactant components. So by default it's methane. So we look for our first reactant, which is nitrogen. So nitrogen, we select nitrogen. Then we move on to the second, and we select our second reactant, which is which is hydrogen. I think hydrogen is beneath nitrogen. Yeah, this is hydrogen. So you also select hydrogen. And also our product is ammonia, so we also look for ammonia and select it. So this ammonia. Okay. So these are selected components. That's the R1 is for nitrogen gas, R2 is for hydrogen gas, and also P1 is for ammonia gas. So our simulator gives us an option for us to automatically balance a reaction or automatically balance a equation. And when it automatically balances it, this is what we get. 1, 3 for the reactant side, and also the product side, the stoichiometric coefficient is 2. So it means from here, the stoichiometric coefficient for the hydrogen, sorry, the nitrogen is 1, the stoichiometric coefficient for the hydrogen is 3, and also the stoichiometric coefficient for the product being ammonia is 2. And since this is just a single reaction, the number of reaction is just 1. And our stoichiometric coefficient, so we start with R1, and we know R1 is the same as the nitrogen. And from this balance reaction, we know is equals to -1 because it's a product. And for R2, which is hydrogen, is giving us -3 from the that's the stoichiometric coefficient. And for the product, which is the ammonia, we also get +2. So 2 here we specify it. And also from my simulator or from the smart material balance calculator, for this we can toggle between moles, molar flow rate, mass flow rate, volume, volumetric flow rates. But since we have a question that's restricting us, it means you are just restricted to the moles. And the moles that was given for the nitrogen in the equation was 100 moles. So we specify it here, press enter, and it shows up here. And the moles for the R2, which is the hydrogen given in the question, was 200. So we type it here, press enter, shows up here. And also the moles for the product wasn't given. So we just leave it blank as it is. And also back in the question, it tells us that 80 moles of ammonia has been produced. So we move back to our simulator, and for here it means ammonia. We select ammonia, which is the same as the P1. P1. So when we select ammonia, then you specify the outlet mole, which is 80. So you press enter for it to apply. And also, Smart Material Balance Calculator has this feature of performing the degree of freedom analysis for us. It when it perform the degree of freedom analysis, they give us zero. And the degree of analysis being zero means our work is solvable. And also gives us the extent of reaction, which is the Z, to be 40, to be 40. So it means for the performance metric setup, we can manually tell that, or even from looking tell that our limiting reagent is the hydrogen. So we select the R2. Then finally, our desired product is the P1, and we don't have any undesired products. So you just run a simulation, and this what we are getting. So the question tells us to find the fractional conversion for the limiting reagent, and the fractional conversion for the limiting reagent here is 0.6, but in percentage is 60%. And also the selectivity, the question told us to find the selectivity. But since this is a single reaction, it means we can't have selectivity like happening here. So we move to the reaction yield. And the reaction yield for single reactions is, you can say it's similar or is the same as the fractional conversion. So that one also gives us 60%. And for the plant yield, for the process, the single reaction that we're considering, that's the production of the ammonia. The plant yield is 3.37 weight per weight. So we can also try computing for these values manually, but that one is going to be tiring and very stressful as compared to we using this smart material balance calculator. So basically, this is what I wanted to present on, and I'd like to end here. Thank you all for your audience.